Hey everybody, it's Kevin from 3D Printed Props. In today's video, I'm going to walk you through one of the more challenging projects I've done in a while. This is a life-size mouse droid from Star Wars. It is RC. This thing moves, it makes noise, and it was a royal pain to do. Okay, so I'm a huge Star Wars fan, Star Trek, all that kind of stuff. And I wanted to start working on some smaller droids. I'm still working on my full-size R2. It's a huge project, but I wanted to start working on some smaller ones. So I thought I'd tackle Michael Baddeley's files for his mouse droid. And this is, I'm gonna say this is no fault of his. His files are perfect. This was one of those projects that no matter what I did, I seemed to make mistakes. It's all on me, but it was super frustrating because if there was a way for me to say, like, these things go on a specific way, right? So I'd put this one on and then I'd put the one in the back, but I'd have it turned around because I wasn't paying attention. Those kinds of things. I had a problem with the paint job. I had to repaint it twice. It's black, that's it. But I was just having problems all the way around. And if you look at the inside, you can see that it is filled with electronics and all sorts of little boards and remote control stuff and batteries that was a little challenging only because I bought a knockoff board for something, and that knockoff board cost me like days and days of me trying to troubleshoot it, but it was just a bad board. But I want to thank everybody over on the Discord and the group over at Michael Baddeley stuff. If you're interested in building droids or Star Wars stuff, check him out. His Patreon will be below. An amazing guy, amazing files. I have been a Patreon member for him for years, even though it's $5 a month. For the amazing stuff you get, it's incredible. And even if I stop printing droids like this, I will continue to just give him my $5 a month because he does really amazing work and his community is fantastic. So let's go ahead behind the fake wall and I'm going to show you how I printed this, how I wired it up, and of course all the links will be below for everything. And then we'll take it outside and I'll show you it move around. Okay, so the first thing I'm going to work on is the main body, and it comes in a couple different pieces. Now, I love this tool for taking off the brim. It is super, super handy to use. And as you can see, Mr. Baddeley actually put in little holes here, and these are just big enough for filament. So you can put in little pieces of filament there to help align the thing. Super handy. And then these little X's really sort of fortify that connection. So I'm using epoxy. You don't probably want to use super glue for something like this because you really want to get some hold in there. And of course, I always wear gloves when working with epoxy because it just gets so darn sticky. Now, look at that, how smooth that goes together using those pins. And again, I'm just working some epoxy into these X's and then pushing these guys in to really sort of help connect that bond between the doors. And now, boom, there you go. You got pretty much a flat piece. This is a really weird piece to sort of try to use clamps on. So I'm using some tape to just sort of pressure hold that together while I go through and add more glue, more epoxy, and more little bits of filament so that I can put the rest of this body together. It went together pretty darn quickly. It's really, really simple to do. Again, just print out a bunch of these little X's. His files are fantastic and really easily to use. Now, I was able to use some clamps for some of these things. I like to always use clamps, especially in mechanical pieces like this, where you really need to get a really good hold. Of course, we watch out for my coffee cup. Don't want to spill that. And this is just 5-minute epoxy. And of course, everything that I'm using is down in the description below. But the clamps really, really help hold that sucker on tight when we just finish up this last of the back. And it's really fun how quick this thing takes shape because it's such a big sort of just boxy shape, but it's kind of neat. Then we're going to work on the lid. Again, more filament, more epoxy,
and then those X's to, again, really sort of hold things in place. And look just like how easy those things snap together. He does an amazing job. I've got my R2 files from him. Any droid from Star Wars universe you want to work on, check out his files. It's Michael Baddeley, links below. His Patreon is only $5 a month. This was probably the trickiest part, getting those little things put together, but I put a weight on it and let it go. Now for the base frame, I did use some metal pegs just to give it some added stability because all the weight rests on this. But again, epoxy and some clamps really make it work. Now this is the actual frame that is sort of the interface between that bottom we just put together and the actual lid. And again, some pegs, weighted it down and just let it go. Now we're going to go to the drive unit. Now this is the trickiest part, of course, of the whole build. You need tons of different kinds of screws and all of those parts. And yes, all those parts will be used. Now the first thing we need is our motor, and links below for this. Now I like to just use a little torch. It loosens everything up and just makes that bolt come off so simple. I hear a lot of people sort of wrestling with this. Hit it with a torch and this thing will pop right off like you just saw it. And it is a little hot. And then you can get a wrench to get the rest of it off and you're totally done with it. The first time I tried this, I worked forever and then I was like, hey, I'm going to try a torch. Now, of course, his files, again, perfect. Lets you fit in these little square bolts so that the screws will then go in and have something to lock onto. Of course, without something like this, really, there's no way to put this thing together. I mean, there might be some way to use some fixtures and some inserts, but just to be able to slide a nut into that space, look at that. And since it's just the right size, you can go ahead and drive the screw right into this for this planetary gearbox. Now, again, his instructions are super clear, but every once in a while, yeah, you're going to have to, take a blade or take some types of tools and maybe just sort of get some of that, whether it's a brim or something to take out to make sure that you can fit your things in. Now, you just saw me put in some things to that bottom part. Now you're going to use a lot of bearings of various sizes. This just helps everything roll along. Again, this is a mechanical piece. It's the drive unit. The battery connects to this and helps drive the wheels to make this thing go. Now I had never used a bearing so large. That thing was crazy. That was a real interesting piece to put on. And now Michael's instructions are really, really easy to follow, but I like to see things. So I'm hoping that, if you're having any troubles, once you take a look at this video, it might, if you have any questions about where things go, hopefully this will help you have a little easier go than I had. But again, through his instructions, I was able to do this, but if this helps you, I'm glad. Now we're going to go ahead and put this box onto the actual motor itself, and we're going to use a little bit of this Lockrite thread to make sure those things, once we tighten them around the axle, around the spindle of the motor, that they don't slip off, right? And look at this, the design. He put a hole there just so we can tighten those screws, because without that, there's no way to get at that, right? Then we're going to use some of this White Lightning grease just to make sure that everything moves smoothly along. This is a little fiddly. You got to make sure moving around the gears so they mesh correctly. And then we're just screwing these in. I'm using this little electric screw gun, sort of like a hobby one, to save my hands, but it went pretty easy. And again, we're just going to keep continuing to put more of these pieces together. There are a lot of them, and this is just the planetary gearbox. There's this is the wheel box. So this is, we moved on to the wheel box. And again, you can see his instructions are right there. I'm looking at them. Everything's got like a groove or a peg, so it can really only go into one place. But some of the pieces look kind of similar, so make sure you're putting the right piece in at the right time. What I did was I looked through his instructions, and everything that said was the planetary gearbox, I put in one pile. The wheel box and the drive, I put them in different piles, and I worked on them separately. You can see there's a V cut out. That goes there. And of course, when you're printing this, you really want to follow his instructions. You want multiple walls. So all these have 4 walls and 25% infill, because these are gears and they're under torque. And you have to make sure that they can withstand the power of that engine, because it is a very, very strong engine. It's actually quite the overkill for this, but it'll do the trick. Oh, here's a little tip. These little cap pieces, that one I just put in, I printed that at 25 infill and 4 holes, and it snapped. So I went ahead and printed a solid version of that, and that one has withheld quite better. So when you see that little piece and you're working on it, I would go ahead and just print that as a full piece. So now we went ahead and we put the wheel box onto the planetary gearbox. We greased everything up so everything moves and slides nice and easy. On the differential gearbox, and this allows the 2 rear wheels to spin at different speeds when turning. So we're just going to snap these things in, and again, you can see little grooves to know where everything goes. We add these screws to tighten things up. Now, I'm not using glue for any of this, and you shouldn't, because if you need to get in there, if something snaps and you need to replace it, you want to be able to just unscrew it and go. And that's the amazing thing about these files. I mean, they fit together, the tolerances are fantastic, and they just work. So these little things here, they're going to go inside. This was probably the fiddliest thing, because you drive a really long M3 through a little bit, and then you put the other gear in, and then you drive it through the rest of the way. And that took me a little bit to figure out, but once I did, I realized, that's how it works. And again, I'm just greasing everything up and adding the bearings where the instructions say to, and then adding more of these pieces in the pipes. Again, this is the differential gearbox, and it's going to be for the wheels to move. And then we're just going to go ahead and put those 4 screws in and slide it around, and it's working out just fine. So now we put some more bearings into this wheel box, and we're going to put the differential in there. And again, the gearbox will make this differential move, which will then move our tires. And you can see you will be using a lot of bearings for this. Take a look at his list of items that you will need. They're in his instructions when you go ahead and if you do one of his Patreons. But that's the great thing. It's not like guessing. What do I need? What do I need? It's all right there. You buy it and you can put it together. And some of the things you might have. If you do a lot of other builds that use screws and things like that, you might just have them as well. Okay, now we are going to work on the frame, and this is the frame of the unit. It's what the drive unit and all that the motor will sit on. It also is what we use for steering. Here we use quite a few of these little tiny bearings so that the wheels can easily move on the frame when the servo moves the steering column back and forth. So here's one of the little steering areas here that we're going to use. And again, look at all these little bearings. They all have 4 on there with a long screw that goes from the top to the bottom, and another bearing, and you put another screw in there. And you can see that this will allow total freedom of movement. If it's a little tight like mine was there on the right, I could just loosen it, and that'll make the tires really easy to move. Now, this gear is the steering gear. This will actually be attached to the steering sort of column and allow the wheels to go back and forth. Once we put this gear, after we snap it a little bit here, we got to cut this off to fit. I'm going to use a little bit of epoxy to hold it in because I don't want that to pop out, because that is going to go on a fairly powerful servo that will move it back and forth. And when it moves it back and forth, it will then be connected to the frame, and it will move the wheels back and forth. But before we do that, we need to put the main part of the frame together. And this just uses, a bunch of screws to hold everything together. Again, I would not glue any of this. If you want to take it apart, you're going to need to do that. But it uses, as you can see, quite a few screws. Now we're going to use this servo, and this is, of course, used for steering. The Arduino code and then the controller we use will know when to move this. We put our little steering wand in here. It attaches to the wheel mounts, and when the servo moves back and forth, it will move these back and forth. Again, just go ahead and use all these screws. You can see that. See how that moves like that? That's awesome. It's so exciting to see something with so many pieces really start to come together and understand how it works. Now we're going to put this box on the back so nothing gets in there and makes it all dirty and grimy and screws things up. We're going to go ahead and put the gear on the servo, mount the servo box onto the frame, and make sure that it locks into those gears so that it can actually turn those. And you can see how it moves them back and forth. Yeah, that looks like an RC car, right? It's incredible. It's so fun to build something like this that you've been playing with your whole life. Now you're actually building an RC car to see how all that stuff works. It's crazy. Now we're putting the main unit onto the frame with a whole bunch of screws. And then now I did test out this motor before I put it in. Always test the motor before you put it in. I did do that because one time I didn't, and I built something around a motor, and then I tried it, and it did not work. Now we're just going to put some of these on. These little pieces here are, again, just to help with stability of the axle. And I'll show you. I tested it again here just to make sure. And there you go. You can hear it running away. I love that little power bank. You can put it to any voltage. Now the electronics, I didn't shoot a ton of video for this because look at it. It is crazy. He has got very, very detailed instructions for this. The one thing I would say is when you are buying the thing that holds the SD card, the little sound player, make sure you buy the brand version. Don't just get like a 10-pack of generics from Amazon, because I bought those and none of them worked. I think one of them did, and then it died. So get the real one. And also, when I'm talking about this little unit, right? That's the Uno. That's the main unit. And when you are supplying power, supply the actual DF player, the media player, the MP3 player, its own power. So there's the little player itself. Give it its 5 volts or whatever voltage it needs. I can't remember off the top of my head. And send 5 volts to the Arduino. Don't sort of daisy chain those. Give them their own power. So last up, we've got the wheels, and these were printed on one of my 3D printers. I can't remember which one. And they are just straight Ninja Flex, really got a good grip to them. And the caps go on, and we just screw those guys on. I wanted to do the rubber tires, of course, to give it a bunch of grip, and these came out really, really well. I hadn't printed Ninja Flex in a while, so I was really happy with how these things turned out. So you just got to screw these on. It's a little tricky. So these are locking nuts because you don't want these things to fly off. So I just held them on with that wrench and then was able to twist it. Then we're going to do some final touches. I like to add, especially when you're using just sort of pins like this, some glue to things to make sure that they don't pop off. And that glue really helps. Put your batteries on with just some zip ties so everything is held in nice and tight. And I just went ahead and tested it again to make sure everything's working before I did what I needed to do, which was finish off some of the greeblies. So yes, you could screw these on, but I'm probably not going to ever take them off. So I just went ahead and glued these and got it ready to put the frame on. So I put this frame unit onto the bottom, and that just uses a bunch of screws. And then I realized it didn't fit, so I had to sort of take the battery off because I had it sort of tied down and it was in the way. So I just snapped that and it was fine. And we're just going to, of course, screw it into the bottom of the unit. And that thing is not going anywhere. Now, how do we hold the main body onto the frame? We use these little powerful earth magnets, and we just go ahead and put them in all 4 corners with some glue. Now what I'll do is I'll drop the one there and I'll put that down. So I know that that needs to go down on the main unit, because if you don't remember these things, and how could you, they look the same, you're going to go ahead and have a reverse polarity going on and they won't stick. So the D there goes down, and I just have them be a little proud because those ones that are in the frame actually recessed a little bit. Now we're going to finish it up with the last of the greeblies and drop those in with just some long screws and then attach them with a nut on the side to really make sure they stay in place. You can see that nut right there. Now, again, you could glue those in, but if I want to take them apart, I can do that, and I figured why not go with a mechanical attachment when I can.
Okay, so this is the maiden voyage of the mouse. I've been waiting for a nice day in upstate New York. This time of year, those are far and few between, but we're gonna go ahead and get this going. Now, since the magnets are holding this on, we just have to pop the magnets and hit the on switch, cap it back up. Then we're gonna turn on our controller. This is the main controller unit for it. We turn that on, and we are ready to go. Which way is forward? I don't know. This way. I have not moved this around yet. Oh, there we go. There we go. I don't know. There we go. Wait, this way. This goes this way. That goes that way. Okay. Come on, buddy.
Yes, he is much better at this than I am. And of course, you can hear the sounds beeping away as it rolls down the road. That thing is moving really well. Nice.
So this was a super fun build. Of course, all these files come from Michael Baddeley. His information for his Patreon is below. All the Droid stuff you ever wanted right there. He's an engineer. He does all the designs on these, and it is fantastic. His Patreon is only $5 a month. Now again, super, I want to say easy build, but it was super doable. Even if you're new to Arduino, following his instructions and taking a look at this video, you should be able to put your own mouse droid together, take it to a con, just have fun with it in the driveway. Again, a really, really fun project. So super fun video. I really enjoyed putting it together. I hope you enjoyed watching this. If you did, please click like and subscribe and hit that little bell so you know when the next video is coming up. And I will see you in the next one.